One of the most complex medical machines ever created is the MRI scanner. An MRI machine may look huge, intimidating, and almost futuristic, but the engineering behind it is even more remarkable. What's truly fascinating is that an MRI can produce incredibly detailed images of the inside of your body. *** without surgery, without opening the body, and without making a single incision. ***, so, how does an MRI actually do this? And what kind of complex engineering makes it possible? MRI stands for magnetic resonance imaging. Instead of taking a direct photograph of your body, an MRI measures the behavior of hydrogen atoms inside your body. It then uses the information from those atoms to create highly detailed images of your internal organs and tissues. But to achieve this, the machine requires an extremely powerful and highly precise magnetic field. And that's where the real engineering begins. Let's start with the most important component of an MRI machine, its magnet. A standard MRI scanner generates a magnetic field of 1.5 to 3 Tesla. For comparison, the Earth's magnetic field is only about 50 microteslas. That means an MRI magnet can be 30,000 to 60,000 times stronger than the Earth's magnetic field. However, the challenge isn't simply producing such a powerful magnetic field. It's keeping that field perfectly stable. Even the slightest fluctuation can reduce image quality. That's one of the reasons MRI machines are so large and heavy. Some MRI scanners weigh more than 10 tons. But how is such an incredibly powerful magnet built? The answer lies in superconducting coils. So what is a superconductor? In ordinary electrical wires, electricity encounters resistance, causing energy to be lost as heat. But certain materials, when cooled to extremely low temperatures, enter a superconducting state, where their electrical resistance becomes almost zero. The MRI magnet is based entirely on this principle of physics. That's why its superconducting coils are cooled to approximately -269°C, or about 4 Kelvin, using liquid helium. In other words, an MRI isn't just an imaging machine, it's also an advanced cryogenic system. And the engineering doesn't stop there. Once the superconducting magnet is energized, the electrical current can continue flowing for an extremely long time without significant energy loss. That's why an MRI's main magnet remains active 24 hours a day, 365 days a year. Even when no patient is being scanned, the magnet stays switched on. This is also why MRI rooms have such strict safety procedures. Before entering the scanner room, patients are asked to remove watches, keys, coins, belts, jewelry, and all other metallic objects. The MRI's magnetic field is so powerful that certain metal objects can be pulled toward the machine with tremendous force. That's why MRI rooms are considered some of the most carefully controlled environments in modern medicine. But an MRI is much more than a giant magnet. Inside the scanner are gradient magnets. Their job is to create tiny, precisely controlled changes in the magnetic field. These small variations allow the MRI system to determine exactly where each signal originates inside the body. Simply put, this is what gives MRI the ability to locate structures inside the body with remarkable precision. But the most fascinating part is still to come. As we mentioned earlier, an MRI doesn't actually take a picture of your body. The powerful magnetic field first aligns the hydrogen atoms inside your body. Then, carefully controlled radio waves briefly disturb that alignment. When the radio waves are switched off, the hydrogen atoms gradually return to their normal state, releasing extremely weak radio signals. The MRI scanner detects and records those tiny signals. Now comes the final question. If an MRI doesn't take photographs, where do the images doctors see actually come from? The answer is mathematics. During every scan, millions of signal data points are collected. Advanced mathematical algorithms and sophisticated signal processing techniques then reconstruct those signals into detailed medical images. In other words, an MRI image isn't a photograph taken by a camera. It's a scientifically reconstructed image created through the combined power of physics, mathematics, and high-performance computing. That's why an MRI isn't considered just another medical machine. It's an extraordinary combination of superconductivity, cryogenics, electromagnetism, high-performance computing, and signal processing, all working together to give doctors the ability to see inside the human body without making a single incision.